In this project, we use gigapixel images to detect cancer. The data we use is a gigapixel image, which can be zoomed in and zoomed out to 8 different levels. First of all, we extract patches and labels from a slide at level 3. The dimension for level 3 is nearly 7,000 by 6,000. Since our data is extremely imbalanced, we processed rescaling, resampling, and augmentation for our data. Window size and stride decide how many patches we could get. Center size decides the labels that we could assign to each patch. This is a window size, this is a center size, and this is stride. Here we use a data preprocess function to extract patches. In order to get a more subtle result, we set window size to be 80 by 80 and the center size 50 by 50 and the stride to be 50. Then we resample and augment our training dataset. If a patch is labeled as tumor, we saved it into our training dataset directly. If the patch is labeled as normal tissue, we generated a random number, and when it's greater than some threshold, we would keep it in order to build a model which can detect tumor areas. As for data augmentation, we applied 8 transformation described in the paper on our training dataset. And this is a transformation. And we choose 0.95 as our resampling threshold and augmented all patches. In order to improve efficiency and focus on localizing tumor region only, we also try to perform foreground segmentation before training a model. And before our final model, we tried several different models. One of them is multi-scale model. This is a model combined from 2 submodels. Each one of them is fed by different levels of image. After some convolutional layer and max poly layer, we concate the 2 models into one, and after concate the 2 submodels, the shape of this layer is 75 by 75 by 64. And in the combined model, we add some convolutional layer and we add a max poly layer and a dense layer. We can see that this is our result for this model. We can find that it is not subtle and the tumor area can be draftily detected. So we are not satisfied with the performance of this model. Then it comes to our final model. We used the idea of transfer learning and built our model based on VGG. Here we did not include top layer, and then add a dense layer with 128 units. Also a global average pooling layer and an output layer with sigmoid activation. Based on our tuning process, we used the window size of 80 and the center size of 50. And this is our final model. We applied all data preprocess methods as I discussed before, like resampling augmentation and foreground preprocessing. The learning rate is pretty small, it's just 0.0001. We can find that, and this is our result for this is the result for our final model. We can find that our model can successfully detect two more areas. The dark red area is the area that our model predicted. And also, we calculated area under curve and the precision and recall, and also confusion matrix. We use confusion matrix to calculate recall precision. And on the test dataset, our area on the curve can reach 0.97. Also, the recall is pretty high. It's nearly 0.97. Although the precision is not much high, so till now we think this model is a good model, and that's our project. Thank you.